My name is Tim Mullen. I'm with Applied Control Engineering, and I'm going to be talking about the impacts of ransomware on operational technology. A little bit about my background. I have a GICSP certificate. That's a SANS cert for Global Industrial Cybersecurity Professional. I specialize in OT assessment and remediation. And the company I'm with, Applied Control Engineering, is a full-service system integrator. We design, install, and program all manners of control systems. I'm from our Baltimore, Maryland office, although our headquarters are here in Delaware, so I'm an interloper in your state. So today I want to go over the differences and similarities between IT and OT, information technology and operational technology. And then I want to review some of the risks that malware, including ransomware, specifically pose to operational technology systems. Some of them you'll be familiar with, and some of them are different from those posed to IT systems. And then we'll have a bit of discussion on ways to limit the impact to OT systems. And then, of course, if you all have any questions, you'll be welcome to ask them at the end. So, OT, what's it about? It's about the machines being in control. Got the laser pointer here? Great. So you can see this is a pretty typical diagram of what some people might call a SCADA system or a DCS, supervisory control and data acquisition, or distributed control system. There's a lot of acronyms in this biz. ICS, IIoT, OT. What it is it's a computer that your engineer or your operations supervisor is going to tell you is not a computer. He's going to tell you it's the PLC. He's going to tell you it's the gateway. He's going to tell you it's the motor. He's not going to tell you that it's something running embedded Linux. He's not going to tell you that it's a Windows XP or Windows CE touch panel that hasn't been touched for 1-2 decades. So this is the challenge, right? Because the people who know what these are don't really know what they are. They know how to use them. And that is more than a full-time job, right? To make the factory, to make the manufacturing plant, to make the power plant run. They know how to use that tool to make that happen. But that is highly decoupled from the kind of the bones behind there. So these are lots of embedded style devices and all of those incumbent vulnerability and visibility and management challenges. Another one you'll hear all the time is that this device doesn't have an operating system, it only has firmware. Well, 30 years ago that meant one thing. Now when your firmware is really an embedded Linux distribution, what that actually means is you can't update your out-of-date Apache web server without taking the whole thing down. You need to get the vendor-approved, specific, entire firmware update. And that cycle is going to be a lot longer and a lot worse than your application-level update. So here are some other differences between IT and OT. So kind of the old saw that people bring out is that IT is focused on confidentiality while OT is focused on availability. So this is going back to the CIA triad: confidentiality, integrity, availability. And this is mostly true. So IT is the space where your important data lives. So this is your credit card information, PCII, HIPAA, all of that. That data is important. The actual information on a person, their condition, their money, that's the thing that's important. And that's totally different in OT because the temperature of your tank, no one cares except for the operator. If it's public on the internet and someone drops your temperature records on Pastebin, 9 times out of 10, no one cares. There's a 1 out of 10 where you're doing R&D or something like that. People like to keep that close to the chest. But it's a different argument. In OT, the technology serves the machine. People are focused on what is this manufacturing cell doing. This robot is picking up milk jugs and putting them on a pallet. this generator is producing electricity. So that is the focus, and the technology just happens to be the way that that occurs. That's a Windows 10 touchscreen interface, what have you. And the machine is expected to run for decades. No one is putting in millions of dollars on that capital equipment and then expecting that they're going to have to refresh it in 3 to 5 years. They're going to run that into the ground. So that's another part of the mindset that's different. Because, of course, we know in the IT space, if you're keeping your servers for 20 years, you're not in business anymore. Or you're running like a legacy Atari website or something like that. IT often has a benefit of specialists. So we were talking in the presentation about how things are moving in the generalist direction, but I think we're familiar with environments where still specialists are required. You have a networking person, you have a cybersecurity person, you have an infrastructure person. In OT, organizations are typically run much more lean. You've got the engineer who's running around trying to make all three of those things happen and more to make product get out of the door. And this is really probably the biggest one. That mindset link between when the machine is down, no product is being produced, that is 100% directly coupled when you're talking about operational technology. The thing is not happening if the technology is not working. So the convergence, that's the other buzzword that comes with IT versus OT. What does that mean? Well, like I mentioned before, OT is using those same technologies as everyone else. Maybe we're about 10 years, 15 years behind the curve, but we're using them. All of these systems typically, and certainly in a new build, are going to be on your bog standard Ethernet network. And it's going to be flat. Both IT and OT systems are critical now for production. Someone scooped me in the last one, because I had Colonial here too. Of course, it was the billing system that ultimately required them to keep the system down for so long during the 2021 attack. But they also didn't have the confidence that their OT network was not impacted to leave the pipeline up and pumping product. Other ways that these two branches really need to be coming together, the design of network and cloud-based infrastructure as new optimization and other algorithms come to play on the factory floor. Those depend on cloud. You need that computing power. And now we have to open the walled garden, or at least peek inside and understand what we're dealing with. So this is just to emphasize my point on, this is a typical still network architecture for an ICS system, especially for a smaller operator. So we've got a flat network still using dual NICing with workstations, no AD. We all know the problems with this, but this is the starting point that we have in this industry. So I talked a bit about the nature of the OT systems, and I touched on their jobs. Here are their critical functions. Control systems enforce human safety. They execute the safety logic that says, when this happens, stop so that someone is not injured. They enforce physical integrity. They say, hey, this motor needs to be shut down or we're going to blow a hole in the pressure tank. And they produce. They execute the logic that makes the product. And from these critical functions, we get to what are the impacts of malware in general on OT technology. We have your big bads here, Oldsmar, Florida. This was someone got into a supposedly disused TeamViewer connection, and they were able to change the lie dosing set point. So this is something where a unsophisticated cyber attack directly changed a physical parameter. Kind of the OG attack is Stuxnet. This is the worst case scenario that everyone pitches of what can happen, and for good reason. So Stuxnet, 2009, advanced persistent threat nation state attacker developed. They developed a malware that jumped the air gap to an Iranian centrifuge facility. They infected both the Windows PCs and the Siemens PLCs, that's programmable logic controllers. That's the industrial computer. And they caused the centrifuge to oscillate between high and low hertz on the drive, and it physically destroyed several centrifuges. So when you think about the worst case of what the worst case consequence of malware to OT is, it's physical impacts in the world. So hazards to human safety and hazards to process. I'm going to talk about the third one, which is hazards to production, because when we think especially about the Stuxnet style attack, that is your worst case scenario, and that is not the starting point of what you should be defending against. You need to hit the low-hanging fruit first. So, and here is why. So in 2020, 33% of attacks against OT were ransomware. This was the single largest type of attack impacting OT technologies. And last year, manufacturing was the most impacted industry. This is IBM's number. True or false? These things are being targeted. Colonial Pipeline, as mentioned, Norsk Hydro, 2019, ransomware shut down several of their production plants. There are other examples of ports being closed. I think that was also in 2019. There was a Coast Guard notice about a port being shut down because of ransomware, again, impacting the control system. And how are they getting in? So it's a soft spot. It's what we know, kind of coming at from the IT perspective. It's the regular computers, right? It's people opening an email and transitioning something onto that OT network because the understanding of the breaks that need to exist between the two is not there. As I mentioned earlier, the operator interface panels, the most common type on the factory floor is a Windows computer, and it is very challenging to get those on a typical type of update, patching, and EDR cycle as it is on the office computer, right? This is something that you may not see. This is something that you may not hear about. This is something that you're not going to be asked for help when it breaks because the integrator or the manufacturer, OEM vendor of that skid is going to be asked to fix it if it breaks. So this concept of the air gap, which has kind of been pushed previously as the end-all be-all solution, it's not sufficient. That's why these attacks are happening. That's why ransomware is preventing people from being able to complete their production process. It doesn't exist anymore. So we talk about the hazards, right? Hazard to production, you can't make product. If the operator cannot interface with that panel, they can't tell the machine to start, they can't load the batch. But that's the immediate impact, right? That's easy for the plant manager or who have you to grasp. The other impacts, which may be just as much or more costly, are how long is it going to take you to get back into production? And do you have that know-how? Because if you don't and you suffer that ransomware attack, your risk is unbounded. You can be in for a world of hurt. So these are the questions that you need to be asking yourself before suffering the attack. What are the components that need to be restored? How do they need to be brought up? Do you know where to find your backups? And do you have someone who can reapply engineering changes? Do you have the licensing and the software that's required? These are some of the bigger impacts that it's important to consider when thinking about ransomware, going beyond the data on that machine being encrypted, because again, that's easy to replace if you have these things in place. Thinking about other actions, how are you going to get to that point where you're going to answer those questions? You should have a policy. You should start small and act in proportion to your needs. Think about what functions are most important to your manufacturing process and start from there. Let that drive your decision making. You should design better systems that don't allow the attackers to have free reign on the network. As I mentioned before, flat networks are still a massive problem. There are lots of standards and frameworks and a lot better understanding now on how to handle those type of issues. IEC 62443, NIST 882 series, these provide the guidelines on how you prevent one lone manufacturer's poor decisions. And by manufacturer, I'm thinking of equipment or skid vendor, what have you, letting their poor practices impact your entire plant. That doesn't need to happen. The zone and conduit approach is effective. Other ways to prevent these issues: retrofit and replace your existing systems. Get off of those Windows XP and Windows CE panels. Use a modern, updatable, centrally managed system. There are lots of vendor and vendor agnostic options for doing this. And take advantage of those established technologies that exist now. So if you can't replace your system right now, think about ways to virtualize or put better layers for remote access in the way so that you're not depending on those out-of-date systems to enforce your security barrier. And finally, harden your systems and keep them up to date. Once you have those systems that you can actually implement effective controls upon, you should do that, again, driven by your policy. Find time during the maintenance outages to update those systems. Make the argument of why it's important to do it now instead of after the fact. Because you'll be executing that disaster recovery plan if you're not. Again, answer those questions beforehand. And this is something, when you're making that argument, that is not only going to benefit you in that ransomware scenario, because that may not be the largest risk to your facility. There's lots of other risks to your OT technologies, right? There's errant driver on a forklift. There's someone hooked up the sprinkler pipe to the conduit. It has happened. There's a leaking sprinkler in the server room. All of these things, if you have your disaster recovery planned out ahead of time, you can anticipate and correct for. If you don't know where your backups are, if you don't have systems in place to take them, you are hosed. And that's it. Does anyone have any questions? Yes.
So I come from the utility
Sure.
sector, and so this is a huge topic
Yeah.
for us. But
What utility? Generation or?
Transmission, distribution,
Okay.
gas. Exelon. So
Okay.
they probably
Yep,
provide
yep.
power too. This is one of the things that I run into consistently, and I'm just curious if you run into it, on
Yeah.
your side as well, is the engineers and technicians that are even managing and working on the systems, have a perspective of I don't want your IT and my OT, right?
Yeah.
That you present an IT control to them, that seems reasonable, and to them it's not, right? Because it's getting IT into OT, and we don't want them to mix, and we're happy with the way things are now, and I'm just curious if that's pervasive or if it's something isolated.
It's not an uncommon mindset, and for good reason, because the person picking up the phone at 2 a.m. when that breaker isn't reclosing is the technician or the engineer, right? So they want to do everything in their power to keep that stable and working as with as little downtime as possible, which means they don't want to change things. So kind of some of the best ways to handle that are, one, get people collaborating in the room together, right? So when it's kind of the top-down approach, it's a lot more difficult to get buy-in because in some sense, you're trying to make it easier for them, right? You're telling them what the control is, but then you have to make the argument of you need to do this. If you get people in the room earlier and it's, okay, here is the thing that we're trying to defend against, this is what the control is intended to deflect, how do we solve this? This is what the current practice is. That's something that helps. And then the other thing that helps is laying out how this can leave in place their existing workflows, because that's the other thing people are worried about is I know how to manage this right now. This sounds like it's going to change how I manage this. It's often not as big of a change as people thought. Dirk?
If I could just add to that, so we've had some success as a systems integrator in being a third party between those two camps, if you will. It absolutely exists. Sometimes they're talking past each other completely, like the IT guy. I'll give you a couple examples. The IT guy said, our recovery time objective is 4 hours. That's the lowest we go. And the guy on the control side was like, no, our recovery time objective is now. If it's not working, it's down,
Yep.
and it has to be fixed. So we had to work through that. I had another example. It just escaped me, but where they don't even kind of understand each other's perspective. And so we came in that situation as sort of like a trusted third party, and we were able to get some things done. Now it doesn't happen overnight, and there's dynamics that you got to deal with. But sometimes it's good to just bring, and it seems strange, bring an outside party that's kind of trusted by both, and yet doesn't have this vested interest of, oh, it's my control system and don't touch it. Oh, I knew what my other example was. Tim gave the example of, it's down, who gets to fix it, right? And the IT guys are like, hey, here's our incident response. We form a team, and meanwhile, these guys are like, no, it's got to be fixed now, and we're going to start just calling people to get somebody to work on it right now. We can't put an incident, right, into the ticketing system.
Yep.
And so it really is in some ways very different worlds, and I understand because I've been living in both in the past, but sometimes a third party can come in and get them to start working together. Because things like backups are typical, right? You might use the same technology to back up your IT versus your OT. Sounds good to me, Virtualization even is something that sometimes they can get on board and say, okay, well, that's going to save us both money. You guys in IT have been virtualizing forever. We'd like to use that, but we're also very cautious about it. The IT guys are like, hey, come on. And the OT guys are like, no, I got to go slow and make sure that I'm comfortable, with how this is being done. Or even put things in the cloud. So.
And I'll say that's exactly what our experience has been. So I'm lucky enough to be in a regulatory environment.
Yeah.
So
Mm-hmm.
we have, requirements we can point to and
Right.
leverage those.
Right.
But sometimes we get put in the middle of that discussion, and we can actually act as that kind of third party, even though we're still within the organization.
Good.
And leverage the requirements for that. But
We did this at a steel company. I've seen it in pharma. I've seen it in refineries in particular. Yeah.
And the other thing we tend to see a lot of too is almost a stepping back of technology, right? So as a means to make it in their mind more secure, they're going to disconnect it from the network.
Yeah.
And in theory that sounds great, but in reality it doesn't always hit the mark.
Well, and just the opposite, you have the executives at top going, look, I can start my car from here. I can see what the temperature is in my house from here. Show me how the nuclear reactor's doing. Okay, or show me, how many pounds of product I produced in the last 24 hours, and what the top 5 causes for downtime were overnight, or why XYZ order didn't get completed. And now I got to figure out how to get more raw materials in place. So that kind of stuff.
Yeah, excellent question. And to add on, Dirk, I'm sure you and I remember that example of how important it is to, when you're trying to bridge between the two organizations, to test how that's actually going to work. Because in that same manufacturer we were working with, IT continued to insist, no, okay, we'll take over the infrastructure. We will be the support. You guys do not have to handle that anymore. Then, of course, they'll get to handle it their way. So it was a Sunday, rolls around, database server dies. OT engineers start putting in tickets with the IT ticketing system. No response for 12 hours. Then they do their method. They start calling everyone whose phone number they have, right? They get the IT director, he's on vacation. They finally work their way down. This guy gets on the chat with the support. He says, oh, they answered my ticket right away. So these processes really need to be tested, because when that transition happens where the support goes from one team to the other, the pathway to actually realize that support needs to be functional. Any other questions? Yes?
It's been a while since I've done anything with these types of systems. But
Sure.
where I was working once, we dealt with building automation systems, and my experience was that once something was installed, it was installed with Windows XPC, that's it for life.
Yep.
It's got to run for 10 years until you totally gut and replace the entire system and all your building thermostats and the whole 9 yards. I feel like a lot of that is vendor issues. Do you see any change in that? I've been kind of removed from it, but I feel like vendors ought to be more supportive of their hardware once they put it out and do software updates. I mean, I could complain my car's the same way. Once the car was sold to me, it's got X firmware on there. They're never going to change it.
Sure.
Even though the infotainment thing dies, halfway through the ride, because Bluetooth is gone.
And for anyone who didn't hear, the question was about vendor support.
Yeah, vendor support in the hardware.
There are starting to be changes, mostly in the fact that the vendors are recognizing that they should stick to what they know best. And so you're seeing people move away from trying to have their own role-based permissioning system to just saying, okay, I'll let you hook up to AD. You can manage it there. So that's one way that the vendors have been responsive, but there's definitely more room for growth on getting into that software maintenance perspective, and that's still lacking sometimes.
I think that's a phenomenal question, because we work for a project company with primarily projects, and a lot of times our customers, they want us to come in and do the project and put in, and we don't sell control, well, I guess we do sell control systems, but we put in all different kinds of control systems, and the customers say, hey, this is what I want, we bring it in, we install it, and then they kind of say, okay, we're done, project's done, we're like, hey, we're great, we're done, do you want us, and they don't necessarily, they expect it to just work then, and they just want it to work, and it does work, okay, but it does get out of date. We come in and do another contract to do support later or upgrade or things like that, but the mindset from the customer is you put it in and it works, and we don't need you to come in once a month or once a year or something like that. It would be good to think about your infrastructure that way, and not just as a project and then it's left alone for 10 years and then it's a project and left alone for 10 years. Instead, have something, maybe even like a cybersecurity checkup, because you can see that things are evolving, right? And somewhere along the line, you put a control system in, somewhere along the line, somebody in the plant says, hey, you know what? We could hook into that and get the data into a database and do big data analysis on it. And next thing you know, your control system's on the network and nobody really even had planned that.
Someone hooked up the Linksys router to make it work.
So we could do a better job of talking that up and describing that to our customers, but also I think as customers we could do better about thinking about the maintenance from a cybersecurity perspective, and as Tim said, software maintenance perspective.
Is there another question over
I
here?
noticed you said you had a lot of you go in and you see a lot of flat networks.
Mm-hmm.
how they're not segmented at all. Are SCADA systems supposed to be, they're supposed to be completely disconnected to the network? Have you ever gone in and seen experiences like that where you have to redo everything in there? Or what's the experience with that? Or?
So, yes, yeah. It's common to have to re-architect the network, mostly because, as Dirk mentioned, a lot of times the way these interconnections happen is, okay, well, we want to pull this little bit in, and then someone makes that happen however they can make it happen, right? So a lot of the network growth is ad hoc over a long period of time, and there really isn't, you have to re-architect at that point, right? You've got a lot of 192.168.1 IP address ranges, and you've used all 250 nodes in there, so. Any other questions?
Do you see a convergence on IoT, like you had mentioned thermostat and
Mhm.
technology there, and this OT, which part of it, for me, OT is like if you have a phone, you push buttons to call someone, that's kind of like what the phone's supposed to do.
Yeah.
But there's like this Internet of Things behind it, there's like networks and there's other pieces. Are they all coming together into one?
As far as, is your question about are the networks and then the functions that things need to
Correct.
perform coming together? It depends. I think most of the critical functions are happening at the local level still. And they need to happen at the local level, right? You don't want to create a dependency for, all of the 10 or 20 independent machines in your packaging line. You don't want to have an interdependency for them to talk to each other, be your external network connection. That would be a bad idea. So you have to keep a certain amount of segregation as far as the local functions have to be performed at the right level. But where things are logically converging is between function and then kind of where those things live is when you get into those big data and kind of analytics type processes where it doesn't make sense to keep those local to the plant any longer.
So how do you fence that off? That's the question. Because if it's old technology, the NT, and it doesn't have the bones in there to begin with, what do you do? How do you get
Sure.
the information out?
So the traditional model is to strictly enforce that DMZ between the business or internet-facing network and the OT network. And that's still the best way to go because these protocols are insecure by default. Anyone who's on the network can tell that motor to start and stop because there's no authentication feature built in. There's no HTTPS equivalent for these type of protocols. Because again, coming from that mindset of the data is not very important, that driver wasn't there of, okay, let's put these in an encrypted tunnel. And then of course, we get all these other things for free. We get authentication, we get a mechanism for authentication and identification. Until those things kind of are fully in place, that traditional model of keeping this network locked down is the best way to go. Yes?
Is any of the malware, the ransomware, going specifically after the devices themselves, like PLCs and the embedded systems, or just the Windows and Linux?
There are. They are now going directly against the embedded PLCs or DCS controllers. So this year, just a couple months ago, in Destroyer 2, which was the second iteration of a Russian-developed malware, they plan to use it as part of the attack in Ukraine. I think it was in April. And this was a malware that directly targeted the circuit breakers in their electricity transmission system. So this was something that it had two prongs, one that was targeting kind of the Windows backend half and was just going to be a typical crypto locker or wiper. But then the other half was going to send bad reclose commands and try to physically break these parts of the transmission system. So fortunately, they were thwarted kind of this time. Apparently, They chose a bad time of the day on Friday. They tried to do it when everyone was going to be coming home from work, but they didn't know that, like, I guess people cut out early on Fridays, so their computers were already off. I think someone gave a presentation at Black Hat this year about it. But so the worst example recently, this is in the past 3 years, was the Triton malware. This is something that directly targeted safety instrumented systems. So these are logic solvers that their sole job is to monitor their set of inputs and say, if it becomes unsafe, close the valves, shut everything off. This is necessary to protect human safety. So this was something that directly went after their controllers. It's been a while since I looked at it, but that is another example. So they are more rare than your typical garden variety ransomware, but they are growing. Any other questions? I think that's it. Thanks for your time, everyone.